Hello, my name is Victor Young,
My name is Forrest Young.
and our project is called Computerpreter. We wish to optimize deaf accessibility through real-time American Sign Language translation.
The problem right now with 11 million deaf and half a million culturally deaf people in the US is that first of all, there are ineffective communication methods. There's also a lack of interpreters, and third of all, there is abundant discrimination. Computerpreter will not make interpreters lose their jobs because Computerpreter is here to fill in the gaps where interpreters are not available to break the communication barrier.
So our solution is a Streamlit app where we have fingerspelling classification and sign recognition for the deaf user and speech-to-text for the hearing user. And the focus of our project is sign recognition, where we use recurrent neural networks or transformers to handle sequential data. And we want to point out that previous techniques like 2D CNNs, they only look at the pixels and not the time aspect, so they are fundamentally wrong.
For our fingerspelling model, we filmed ourselves for data and we used media pipe hands to extract landmarks to remove algorithmic bias and to increase efficiency. Our best model was an MLP with a test accuracy of 98.84%. For our dynamic sign classifier, we got data from WLASL, MSASL, and ASL Citizen. We used media pipe holistic to extract landmarks, and our best model was a residual temporal CNN with regularization. As you can see here, the validation accuracy went up and the loss went down. Our best test accuracy was 88.1%, which is very solid as well.
Finally, we notice a problem, which is that ASL grammar and English grammar are very different. So, to transition from our raw predicted ASL gloss to English sentences, we used OpenRouter's free LLM API key, and we gave it this content prompt up here. For the hearing user, they will use speech-to-text functions from OpenAI's Whisper model, and so that both users use their natural language. Finally, on the bottom, you can see that we envision deaf and hearing users to use phones, fold or flip phones, or simple phone holders. They're great for signing to the camera. Here's the flowchart. Notice the blue arrows for the deaf user inference loop. That is the main part. Now let us look at our demo video. Here is a deaf person.
I'm a hearing person, and today we're going to have a conversation using Computerpreter.
You can see that first, the deaf person would like to communicate using dynamic sign. We are detecting the landmarks on the body, face, and hands, and after the signer signs, you can see the predicted word on the model. And we'll temporarily store all of these words in a string to give to the LLM API to get the translated English sentence, as you can see right now. And the English sentence will be in the chat box. Now the hearing person would like to respond.
Because it's delicious and healthy. What's your favorite type of meat?
So you can see that the hearing person just responded. He can click transcribe audio to turn his audio into text for the deaf person to read in the chat box. And now the deaf person would like to respond using fingerspelling. You can see that for fingerspelling, we are also detecting landmarks, but it is on the hands only, and it is continuous, because fingerspelling is static, hand shapes. We'll store all of these predicted letters and use a sliding window algorithm to print out the final word.
That's really cool. Mine is steak.
You can see that the deaf hearing person just responded again and clicks transcribe audio to turn his audio into text for the deaf person to read. So you can see that for a full app, it is fully free and it is fully functional on the web, and our code is also fully open sourced in GitHub. Finally, both users can also type some fun emojis. We went to our local deaf community and we interviewed many people. Mr. Thompson from Source and Communications, which is a international company for deaf technology, Miss Tully, our 29-year ASL teacher, and many deaf students and deaf teachers at our local deaf school. In total, we got more than 200 responses.
So why us? Why Computerpreter? Well, as you can see here is the competitive value curve. ASL Citizen, their research is not an app, and their results are even worse than ours. Government-funded VRS, that's interpreter for phone calls only, so by law, the two parties cannot be in the same room. For VRI by Sorensen Communications, that is similar to VRS, but it must be paid for by the organization, so it does not solve the problem. And professional interpreters, of course, they need to be planned, and hiring is costly. Here is our market. ASL is the third most commonly used language in the US, and the CAGR is 9.2%, which is very good. TAM is $400 million per year, SAM is $35 million per year, and SOM is $500,000 per year. Here is our go-to-market strategy. First of all, we will engage the deaf community and let the deaf community adopt Computerpreter. Thus, we can crowdsource data and have specialized vocabulary. Then, we will embed Computerpreter in apps like Zoom to expand the market, and finally, on a national scale, we will expand to other sign languages for deaf people all around the world. Here's our 3-year financial projection. On the first year, there will be some starting losses, but that is expected and very fine because on year 3, we will be in a very safe financial position and we will know what to do next. Over 5 years, to have Computer be a successful national AI startup, we'll need $2.1 million. That is a significant investment, but we know that with the good market and our own determination, we can do it.
Finally, we estimate that Computerpreter can save deaf hearing conversation times by up to 62%. And the best thing about our app is its accessibility. Simply go to computerpreter.streamlit.app. Thank you.
Thank you.